Okay, page 8 in your note packet is 2-2 linear equations. So at the top there, a linear equation and function is an equation whose graph is always a line. So now we're going to talk about just lines. We have no exponents larger than 1, so we're not going to see an x squared and x cubed, anything like that. It can be written of the form f of x equals mx plus b. Remember, this is just fancy y. Y equals mx plus b. Okay, so look at number 1 there. It says, is each function a linear function? If I were to graph that guy, would I see a line? 2x plus minus 5. Yes, okay, so that guy's linear. My slope is 2, my y-intercept is -5. How about letter B? P of x, there's a different letter and that's okay, it's just fancy y. P of x equals x cubed plus 2. No, we have an exponent bigger than 1, so this guy is no, because of that guy right there. How about letter C? T of x equals 4 plus 7x. Yeah, that's okay. It's just in a different order. Okay? The stuff that we skipped talked about all of those properties of addition and multiplication. That's the commutative property that says I can do it in any order I want and it's still the same thing. So technically this guy is still in the form 7x plus 4, right? So it's okay. What if, and this one isn't on there, but what if my slope were 0? So what if I had something like 0x minus 5? Is that a line? Yeah, he's just a straight line, right? And that's okay. So instead of writing it 0x, though, I would just write something like f of x equals -5. And that's okay. We'll look at one of those on your worksheet. Okay, so y equals mx plus b form. And then the next one, any questions on that? Okay, so that's linear form, f of x equals mx plus b. Standard form. Any linear equation can be written as ax plus by equals c. A, B, and C are always integers. Okay, we sort of skipped that little part too about integers. Okay, integers are numbers that are positive and negative numbers, but there's no decimals and no fractions. Okay? Ooh, I gotta scoot over. Zoom out. There we go. All right, so the numbers in front of all of my variables cannot be decimals, they can't be fractions. And one last hint, A is positive. And the greatest common factor is 1. That means that there's not some number I can divide them all by. Okay, if they all have a common factor of 2, then I would divide them all by 2. Okay, so standard form. ax plus by equals c. We put the variables on one side, we put the constant on the right. The constant's just the number. Sometimes we have to rearrange them. and that's okay. And then we fix it so there's no decimals, no fractions. A is positive, and they don't have anything in common. All right, so if I look at this guy right here, y equals 3x minus 9. I want to put my variables on one side and my constant on the other side. So what do I need to move? The 3x, okay? So I'm going to move the 3x to this side by subtracting him, so I get a negative 3x. Plus, I'm going to put a 1 in front of the y just to make our life easier. Equals 9. Negative 9. Now, a is supposed to be positive, right? So how can I make a positive? Yeah, multiply or divide everybody by negative 1, right? So I get 3x minus 1y is equal to a positive 9. So I have both of my variables on the left-hand side. My constant is on the right-hand side. A is the coefficient of x, B is the coefficient of y, and C is my constant. So what's A? Three. What's B? Negative 1. What's C? 9. So this is my standard form. Then it told me to list out what A, B, and C were. Okay, let's try B. Look at B. I have negative 2/3 x equals 2y minus 1. We got lots going on. We have an x on one side, a y on the other side. We have a fraction, a is negative. Let's go ahead and move that y to the other side. So I'm going to subtract 2y. So I have negative 2/3 x minus 2y is equal to a negative 1. All right, now we have to fix some things. Could we get rid of the fraction and make it positive all at the same time? Multiply it by negative 3, right? Is that what you said, Thomas? Yes, that's exactly the same thing. So yes, you are correct. So let's multiply everybody, and I ran out of room, so I'm distributing a negative 3 to everybody. So when I take a negative 3 and I multiply it by a negative 2/3, what do I end up with?
2.
Positive 2. And I'm going to multiply a negative 3 by a negative 2. And I get positive 6y. And a negative 3 times a negative 1. And I get a positive 3. Okay, double check it. Are x and y on the same side of the equal sign? Is a positive? Did we get rid of all the fractions and there's no decimals? Woohoo, we did it. Okay, now, the greatest common factor, there's common factors between the 2 and the 6 and the 3 and the 6, right? However, there's no common factor between all 3 of them. So we're okay. So what's A? 2. What's B? And what's C? Okay, last one, letter C. I have 8x minus 6y plus 4 is equal to 0. Let's move the 4 over. So I'm going to subtract it so he becomes a negative 4. Do they have something in common? Is there some number I could divide all three of those by? 2. Let's do it. A is positive. We don't have decimals. We don't have fractions. They don't have anything in common. So 4x minus 3y is equal to a negative 2. We would only divide by negative if this guy were negative as well. So if the 8 were negative, then we would divide by negative 1 or negative 2. I don't know if that answered your question, Romy. Did that did? Okay. Okay, so what's A? B can be negative, so he's negative 3. And C is negative 2. Now, what's the point of having this standard form, right? Well, sometimes we just practice graphing them in this form right here, right? When we had it like mx plus b. We know how to graph that way. We've been graphing that way forever. Okay, we graph that way in Algebra 1, we graph that way in geometry. We've been graphing using that slope-intercept form for a very long time. Yes, that still works. But sometimes our problems aren't given to us in nice, pretty slope-intercept form. Sometimes they're given to us like this. When they're given to us like that, we can graph them using our intercepts. Okay, intercepts are where they cross each axis. So my x-axis is where x-intercept is where it crosses the x-axis. When it crosses the x-axis, that y value is 0. Okay, so the x-intercept is the x-coordinate of the point where the graph crosses the x-axis. Okay, on the x-axis, the y-coordinate of the x-axis is always 0. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. If it's crossing the y-axis, no matter where it is, the x-coordinate is always 0. And if you remember from geometry, it only takes 2 points to graph a line. So I'm going to find out on my graph where it crosses my y-axis, where it crosses my x-axis, and then I can just connect them. The nice thing happens when it's in standard form, I can graph them by intercepts. And you're going to hear me call it the cover-up method. Okay? So look at number 3 there. Number 3 says find the x-intercept and the y-intercept of the graph, negative 2x plus y minus 4 equals 0. Okay, let's put this guy in standard form first. Okay, so you can see it a little bit better. So if we're going to put this guy in standard form, what do I need to do?
Move the y.
Try move the 4. Ax plus b, y equals c. Let's go put it in this form. Whoop, that form. Okay. Yes, we could also do it the other way too. I'm going to add 4 so he becomes positive. Now, technically, if we're going straight standard form, what's the problem there? The negative, right? Okay, so let's divide everybody by -1. So I got positive 2x, or multiply if you will, minus 1y is equal to a -4. Okay, so we put that guy in standard form. We could have also, JJ, I think you were going to slope-intercept, which is perfectly fine. So sometimes it gives it to you in this form right here, and we can graph it with our intercept. Okay, let's find the x-intercept. If we're finding the x-intercept, I'm going to say y is equal to 0. If I plug a 0 in for y, what happens to this whole thing right here? (2x minus 1 times 0 equals a -4. What happens to that? When I multiply by 0, it stays 0, right? That guy goes away completely. And this is why I call it the cover-up method, because I'm covering it up with my finger. For lack of a better word. So I'm left with 2x is equal to a -4. So what's x equal to? -2, right? I now have an ordered pair of -2, 0. I'm going to graph it on my graph. Okay, my y-intercept. My y-intercept said my x is equal to 0. Okay, I'm going to plug 0 into my equation where x is. 2 times 0 minus 1y is equal to a -4. Again, I'm multiplying by 0. So he's going to stay 0, and then he's going to go away. So I'm going to cover him up. So I have -1y is equal to a -4. Divide by -1, so y is equal to +4. So now I have an ordered pair of 0, 4. And I'm going to graph him. He's crossing my y-axis. My x is 0, 1, 2, 3, 4. There's my 2 dots, and I'm just going to connect them. So the beauty of standard form is that I don't have to always rearrange it. Now we rearranged it a little bit, but usually they'll give it to you in standard form sometimes. If you don't have to rearrange it and they give it to you in standard form, I can just cover up my x, figure out what y is. I can cover up my y, see what x is, and I can graph both of those 2 points. Questions on intercepts? Okay, the last 2 things down there at the bottom of your paper talk about vertical lines and horizontal lines. Vertical lines are of the form x equals a number. So x equals 3. That's going to be a vertical line. There's no slope-intercept form for that. Okay? He's also not a function. All of his lines are a vertical line, so he doesn't pass the vertical line test. Horizontal lines are of the form y equals a number. Just say like x equals 3. So this could be like y equals -7. And those guys are functions. Think about them like that. And you can write them in slope-intercept form. Y equals 0x minus 7. So my slope for horizontal lines is 0. My slope for vertical lines There isn't any because there's no slope-intercept form of that line. Okay? Questions?